Section 4.1, radians and degrees. So the first thing we're going to do is we're going to do some sketching here. So let's take a look at A. Now keep in mind that if we're going to have, so let's go off to the side here for just a second. Sorry, I kind of jumped the gun on that. To have a positive angle, we start from the x-axis and we go up. So in that direction, that's going to be a positive angle. To do a negative angle, we're going to start from the x and we're basically going to go down. So that's going to be a negative angle. So keeping that in mind, let's go through and graph 195 degrees. So I need my axes. And again, they don't have to be gigantic, just kind of big enough to hold the graph itself. So it's a little too large. All right. So now, starting from the positive x-axis, because regardless of which way, regardless of how large the angle is, or if it's going to be positive or negative, you always start on the positive x-axis. So starting on the positive x-axis, I need to go 195 degrees. All right, so I'm going in the positive direction, which means I'm going to go up. So that's going to be 180. Then, to get to 195, I need to go 15 more degrees, so really not very far. You're going to make sure that you draw the arrow so you can see exactly what direction you traveled in, and then draw the terminal side as well. So there's a pretty decent sketch, I think, of 195 degrees. All right, let's move on to the next one. Go ahead and get our graph ready again. Seem to be getting a little out of control of the size with my graphs here. All right. So now I'm going to do a negative angle this time. So I'm going to use red for negative, just so we can see it. All right, so we need to go 445 degrees, which means we have to go further than 360. So I definitely have to go a full spin all the way around. Now that's traveled 360 degrees. I need to go an additional 85 degrees, which gets me almost to 90. Draw my arrow, and then draw my terminal side as well. Make sure that you start from the positive x-axis, that you go in the direction that you need to be traveling, so either up for positive or down for negative, and you need to draw the arrow, and you need to draw the terminal side. Okay. So we're going to do the same thing here with 930 degrees. Once you have the graph already set up, why don't you go ahead and pause it and see if you can graph 930 degrees. I'll do the same. I'll sketch it and then we can compare. Okay, so here's my 930 degrees. I know that I had to go 360 once. Then if I go an additional 360, that gets me to 720. Once I'm at 720, I need to go an additional 210 degrees to get to 930. So there are my sketches for my first couple graphs. Okay, number 2 and number 3. So now based off of the directions that we have, what we want to do is we want to be able to sketch it. That's one thing. But we also need to be able to convert it. That's another. And then we want to find coterminals based off of the conversions themselves. So I think the first thing that I am going to do is I'm just going to go ahead and graph this, just like we did on the previous page. Let's go ahead and set up our graph here. Again, it doesn't have to be all that big. And this is a positive angle, so I think I'm going to go ahead and use green. And if I go 135 degrees, that's 90 degrees, plus an additional 45 degrees. So I believe our graph is going to look like this. So there's our 135 degree angle. Now what we need to do is we need to convert this thing. So we have it in degrees right now. What we want to do is we want to go to radians. To go to radians from degrees, we take the original degrees that were given to us, and we times it by pi over 180. All right, so if we multiply straight across, it's going to give us 135 pi over 180, but that can be simplified. So this is going to give us 3 pi over 4. All right, now we have it in radians. Now what we want to do is we want to get coterminals. So to get a positive coterminal. I know hopefully this goes without saying, but if you want a positive coterminal, it means you want the answer to be a positive number. Silly, I know, but you want to make sure that you check at the end. So we're going to take our 3 pi over 4, and to be coterminal means you just put in a full rotation. So I'm going to add 2 pi to this, since 2 pi is once all the way around. If I get a common denominator of 4 and I add them together, I'm going to get 11 pi over 4. Now, there are an infinite amount of positive coterminals. You could just keep adding 2 pi's over and over and over and over again, but I know that adding 2 pi will suffice. So, plus, I don't want to spend too much time doing some sort of addition or subtraction where I know my time could be better spent on more challenging problems. Okay, a negative coterminal. All right, negative coterminal, which means it's going to be a negative number at the end. Go back to the 3 pi over 4 that you started with, and instead of adding 2 pi, I think I'm just going to subtract 2 pi. Which means that's going to be a negative 8 pi over 4, and if I subtract, I'm going to get negative 5 pi over 4. Now I'm happy with that because it's a negative number. So those are my answers for 2. Let's take a look at 3. Alright, so on 3, I have a negative 11 pi over 12, so this time I have a radian, and my job is to get a degree. You can graph this now. I know in the beginning some people are a little concerned about being able to figure out where their graphs are for these, though, especially with the radians, because you're not too comfortable with them now. The idea is you still need to be able to convert, so if it helps you to convert first, convert first. Then, if you feel like you have a better idea of where the graph is going to be or where the terminal side is, then do it that way. It's perfectly fine. It doesn't matter which one you do first. Eventually, we just need all of it done. Okay, so I'm going to get my graph set up, but I think I'm going to wait and do the conversion first. Just because this is the beginning for you, so we'll try to make it as what I think is probably going to be the easiest way for you. All right, so degrees. If we are already in radians, so we take our radian, negative 11 pi over 12, we're going to times this by 180 over pi to go from radians to degrees. If we multiply these, the pi's are going to cancel, and simplify, we get negative 165 degrees. Alright, so I'm a lot more comfortable, or I believe most of you would probably be more comfortable with that than the radian. So negative 165 is almost negative 180. It's super close, but it's a little bit short of it. So I would say it's probably about right there. Pretty close. Alright, so now that we have this, we can go ahead and do our positive and our negative coterminals. So we've got our positive coterminal here. Now since we're in degrees this time, I'm not going to use 2 pi. I'm actually going to use 360, so one full spin. So positive, so if I add 360, I think that's going to give me a positive degree, and it does, it gives me 195. Alright, so there's a positive coterminal. Now if adding 360 once didn't get me a positive coterminal, then add 360 again. Keep adding 360s until you get to that positive number. Likewise with a negative coterminal. If subtracting 360 or adding 360 still doesn't give you the negative number that you need, you just keep right on going with the 360s. So in this case I'm going to subtract, and that does give me a negative number, negative 525. So again, make sure that if you have a positive coterminal, you actually have a positive number, and if you have a negative coterminal, you have a negative number. Okay, our last couple questions for this set of notes. We want to find the complement and the supplement. We're not going to convert, so we're just going to stick with what we've got here. Okay, so just a reminder, complement means that we have values that are going to add up to 90. So we want to add to 90 degrees, which we also know is pi over 2. If we have the supplement, then that means we're going to add to 180, which is also pi in terms of radians. So that's what we're going to do. Alright, so we want to find the complement and the supplement. So complement I know that I'm going to have pi over 12 plus something, let's call that something x. And if this is already in radians, then let's just stick with radians. For complement, it's going to be pi over 2. So I'm going to go ahead and subtract my pi over 12 from each side. When I do that, I am going to get x is equal to 5 pi over 12. So there's my complement. All right, my supplement, I'm going to do pi over 12 plus, I'm going to use y this time just because I don't want to get my variables confused. And then when I subtract, I'm going to get 11 pi over 12. So there's my complement and my supplement for the first one. For b, I'm going to do the exact same process. But now that I'm in degrees, I'm just going to go ahead and stick with degrees. So complement is going to be 83 plus something is going to give me 90. Well, when I subtract, I'm going to get 7 degrees. My supplement, same idea. 83 plus something has to give me 180. When I subtract, I'm going to get 97 degrees. So my complement is just adding to get 90 or pi over 2, depending on what's given to you. And my supplement is adding to 180 or just adding to pi, whichever is given to you.